I'm the one who is going to be with you for upcoming 5 days for this webinar called as 5 design patterns in 5 days. Every night at the same time, we'll continue to meet at the same time, and we will pick up a design pattern. We will learn it in a very, very crisp and clear manner. And we will also figure out where to apply those patterns, how to apply those patterns, and we will back it up with some small case studies. Okay, that's what we'll be doing. So my name is Vivek, and I'm also one of the co-founders here at Programming Pathshala. And I was a software developer with Amazon for around 2.5 years, from 2016 to 18 or something. And I did my studies in computer science. I did my BTech from IIT BHU. So that's a short intro from my side. Here at Programming Pathshala, I have to take care of a lot of things. And one of those things is academics and teaching people, figuring out the important skills that are industry relevant, and to teach them in as lucid manner as possible. That is what I do. Yeah, so that was a short intro from my side. I think we can start. Few things that I would want to ask you just to get things started is, how many of you have found it out that the amount of time taken by you to read the code in order to figure out where the change is to be made is much more than the amount of time taken to write the code? In simple words, what I mean is that you spend more time reading the code, testing the code, rather than writing the code. Have you felt it at any point of time? It happens most of the time, right? See, if you join a new team or if you join a new company, and your manager tells you that, hey, this feature is broken, I want you to fix that feature. Now, the most important thing for you is to figure out where that feature is. Then only you can figure out what exactly is wrong, and then possibly you can fix it, right? So that process of finding out where that code exists, that is most tedious. That might take you 1 day, 2 days, sometimes even a week. And the code change that you would have to make could just be a one-liner code change. Yeah. So the important thing is that it's very essential for code to be highly readable and highly testable. Okay, a code that is not readable, it cannot be understood, it cannot be it'll take a lot of time to figure out where what changes to be made. And low level design is just an attempt to make sure that the code is highly readable, highly extensible. Today, whatever we are going to study, that will give you a very solid idea of what I mean by extensible. Okay, so yeah, let's start. See, there are two things. The first thing is low level design, and the thing which is even basic than that is OOPS, object oriented principles. So what is OOPS? I want to know your idea about what do you think it is. You can write it in the chat box. What is OOPS and how is it different from low level design? It's just a very beginner level question. Please answer it. OOPS is the building block for LLD. Okay, so one person has responded so far. OOP stands for object-oriented principles, right? So it's a paradigm. It's just a paradigm. Different languages have different paradigm. And OOPS offers 4 most important things using which it is very easy to write maintainable, extensible code, right? So you might have known, you would definitely know about all these 4 pillars, like you have abstraction, encapsulation, polymorphism, and inheritance. Okay, out of these, the most important thing is polymorphism. Okay, polymorphism is something that allows us to write extensible systems. Because what is the meaning of polymorphism? Poly means many and morph means form. So multiple forms of something. That is what it means. Okay. Now, when you say polymorphism, then how does it actually help to write a code which is highly extensible? So we'll try to understand that. I'll give you a very simple example, a very layman example to set the context for now. For that, I'll have to share my ID. So let's say you just go ahead and create a random class. So whatever examples I'm going to take for now, I'm going to take them in Java, but the concepts that we will primarily be covering, they will be language agnostic, okay? Because I have to pick one language. That is the reason I have kept it Java for now. So let's say you go ahead and write a class. You say that that class is, let's say, animal. Okay, this is a class. Now, what you end up realizing is that, hey, there can be different forms of animals, right? So if there is a class called as animal, that will have some methods that are associated with animal. So let's say there is a method called as make sound. Okay. Now there is a make sound method, and let's say this is a void method for now. The way this method will be implemented will be very, very different. It will be very, very different for a cat, for dog, for elephant, because all these, animals produce sound in different manners, right? So if you have to implement this method, then there will be so many if-else conditions that will be coming up. Let's say somebody wants to go ahead implement it. Then he'll have to put a lot of if-else check. If the animal is a dog, then make such kind of sound. If animal is cat, make such kind of sound. So there'll be so many if-else conditions that are going to come up. But the idea of polymorphism says that think in terms of two things. Think in terms of supertype and its subtypes. So what I mean by that is, whether you have a cat or dog or donkey, whatever, all of them at the end of the day are nothing but animal only, right? So super type is animal, okay? Super type is animal, and subtypes are those actual concrete animals. So let's say cat or dog or fish or whatever you have, right? Those are your subtypes. So because all of these are subtypes of this super type, so what we can do is we can create a subtype, and then this subtype can have certain properties that are common to all these subtypes. So what I mean by that is, all the animals are going to have certain common behaviors for sure, like making sound, and maybe making sound and eating, sleeping, all sorts of things. So imagine those things are just like different methods. The only thing is that the way these methods are implemented inside of these animals, that is going to be different, right? So for that, people came up with a notion of polymorphic type. Now, what is polymorphic type? I'll just quickly get rid of this. So there are different, uh, you know, uh, kinds of polymorphic types in different languages. You have got something called as interface. You have got something called as abstract class. I believe a lot of you would have heard of something called as abstract class. So I'm going to make this as an abstract class for now. Now, if this is an abstract class, it can contain an abstract method inside it. So let's say there is an abstract method, abstract void, make sound. Okay. Now, if a method is abstract, what does it mean? It means that you do not have to implement it. It will be implemented by the subtypes of this animal. Everything that is an animal, like cat, dog, donkey, all of them will implement their own version of make sound. Okay. So if let's say I go ahead and create a normal class, which is not an abstract class. So let's say I create dog. Then I would say this dog can extend that animal, right? And now because it extends that animal, so it will be forced to implement the methods that are declared as abstract inside this animal. It will be forced to do so. So now you can see that inside this dog, there is a make sound method, and I'm supposed to implement it. So I can say this just system.out.println woof, something like this. Okay. So you can see that this dog has extended animal. So it is, inheriting the properties of animal. So now similarly, you can go ahead and create another class. Let's say you wish to create cat. Now, if you create cat, and if you want cat also to be a subtype of animal, you can do something like this. And because of that, you'll be forced to implement this make sound method. And you can implement it the way you want. You can say, here I'll print new, something like this. Okay. Now, so far, the only idea that we have understood is that there is a super type, which is animal, and then there are subtypes like dog, cat, donkey, everything. But even more important than this, the point that I want you guys to understand is, let's say now I have a random class. Now here I'm writing my main method. Now, let's say I have created an instance of animal. I have created a variable of animal. Okay. The important thing is that this animal variable, it can point to a dog also, and it can point to a cat also. So you can do animal equals to new of dog. It's perfectly okay. And at the same time, you could also have done animal equals to new of cat. You could easily have done that. Okay. Why? Because this animal thing is a polymorphic type. It can point to multiple subtypes. Okay. Now, if you have done something like this, and let's say you are invoking animal dot make sound. If you are invoking this method, what would happen is that, see, this animal is actually an abstract type. Here, make sound is not implemented. But if you look at the code that I have written here, this animal is pointing to a cat. So if you do animal.make sound, then make sound method, which is implemented inside the cat, that method will run, right? Similarly, if let's say this was not a cat, rather it was something like a dog. In that case, if you would have done animal.make sound, then the sound that would have been produced would have been sound of a dog. So this is the idea of polymorphic type. With this, what we understand is that one variable can actually accommodate multiple types. And because of that, if you call certain method on that variable, the output of that method depends upon what was the type that it was pointing to. If it was a dog, it will be barking. And if it was a cat, then it will be producing that cat sound. Okay. But the key idea over here is that just imagine that there is a function. There is a random function. Let's say I have written a public static method. I'm just calling it func for now. Let's say it's void. And this method in its argument takes animal. Now, what it means is, because this accepts an animal inside it, it means I can pass an instance of dog also to this method, and I can pass an instance of cat also to this method. So you can just say it. I can simply call func of new of dog. That's totally okay. And it could also be cat. Anything, any type that is an animal that can be passed to this. So it means that this function is extensible. Why it is extensible from the point of view of the arguments that it accepts. So it accepts all sorts of animals and probably does something on top of them. Okay. So this was a very, very basic idea of polymorphic type to bring all of you at the same page. The gist is, if something is polymorphic, that means it can accommodate multiple types. And if it can accommodate multiple types, that means it can behave differently depending upon what the type is. If it is dog, it behaves differently. If it is cat, it behaves differently. Is that making sense? Are the things sounding clear so far? You can just type in yes or no. So that was a very, very basic introduction to what these polymorphic types are. Now, there are a few more things that you have got to understand. See, when I talked about relationship of super type and subtype, I said animal is a super type and cat and dog are subtypes. So it can be thought of as a parent-child also. Animal is a parent and cat and dog are children. Now, if children inherit something from parent, then yeah, if a parent had some bank balance, some properties, they inherit those. But those children can have something that are specific to them also. So let's say dog has a method which is specific to dog, and let's say that method is sniff, because only dogs would sniff, not all the animals would sniff. Okay. Similarly, let's say cat also has some method. Let's say that method is catwalk. So catwalk is a method that only cats can do. Now, I would ask you a very simple question. Let's say I go back to this main, and here I create something of type animal. I call it A, and this is equals to new of dog for now. Tell me one thing. This A is of type dog, and inside dog, I just created a method called as sniff. Now, my question to you is, can I do A dot sniff? So I'm not going to do that right now. I'm just going to ask you what do you feel. Can I do A dot sniff? Will that be allowed? So one person is saying no. Okay, let's try that. When I do A dot, then I'm not getting any suggestion of sniff. I can write it forcefully, but that's not allowed. Why it's not allowed? There is a very simple reason for that. Your system right now just knows that this variable is an animal. So the methods that are associated with animal, only those methods can be called on top of that. Okay, so inside this animal abstract class, only the methods that are there, those methods can be invoked. Nothing else can be invoked. And do you know why is this so super important? Why is it done in this manner? I'll tell you. See, let's say somebody does A dot, somebody tries to do A dot catwalk. Okay, then how will it be how will it be ascertained whether this catwalk method is applicable to this A or not, right? Because different subtypes can have different methods that are specific to those, right? But if you have a variable which belongs to polymorphic type, then only and only the methods that are declared inside those polymorphic types, you can call them using that. You cannot basically call the methods that are specific to dog or the methods that are specific to cat. Yes, if the type of this was cat, then there was no issue. If the type of this was cat, then I could have easily called A dot catwalk. But if it is animal, that cannot be done. So you can think of it in this manner. If I say that there is a class that extends another class or that implements an interface, then you can think of it in this manner. Imagine that this animal class is like a small ball, and inside that ball, there is a method make sound. And once you have cat, then that cat is like a bigger ball which is wrapped around that ball. So it means that the methods that cat has, those methods are basically are lying on top of the methods that it is inheriting from its parents. So if you want to call catwalk, then you have to have an instance of cat. You have to have a variable of type cat. But if you just have something of type animal, then that would basically not be possible. So this was an important point to understand, that using polymorphic types, you can invoke only and only those methods that are specified inside that polymorphic type, not inside the concrete types. Okay, great. So now once we understand this idea, what we will do is, so we know something like polymorphic type exists and all. Now, no matter which language background you come from, we will take a question. I'm pretty sure that a lot of you might have encountered a problem like this. So let's say, let's do something new. So all of you might have written programs to sort some data, right? So I want to write a very simple class. I want to give it a name, sorter. The responsibility of this class is to sort a list of integers for now. Okay. Now, so the things that it takes is, it takes a private list of integers. So I'm going to call it my list. Okay. And now it has a simple method inside it called as sort. So it has a public void sort method. The responsibility of this sort method is to sort this list of integers, as simple as that. Let's make it final for now. We are passing it via constructor. Okay, so tell me one thing. All of you know a sorting algorithm, so you can write that sorting logic and the job is done. So let's say the simplest sorting algorithm that you know is of, let's say something very, very similar to selection sort. So let's say I run a loop from 0 till my list dot size I plus plus, and here then you write int j equals to, let's say, I plus 1, j is smaller than this, and j plus plus. And now I'm not doing anything special. I'm just sorting. Okay. So if you find out that my list dot get of I, basically if it is greater than my list dot get of j, if that is the case, then you will have some logic inside this block which will be responsible for swapping. So that's simple logic for sorting this. Now, what I want to do is I want to make this method little generic. So what I mean by generic is, see, currently it is sorting in increasing order only. But have you encountered a case where you might want to sort your data on different criteria? So sometimes you might want to sort your integers in descending order. Sometimes you might want to sort those on absolute values. So it's a very classical case. Let's say you have a data which is 5190 minus 6 minus 2 3, something like this. And if somebody says sort this data, then at times he might want to sort it in ascending order. So if it is ascending order, your output will be minus 6, minus 2, 0, 1, 3, 5, 9. If it is descending order, then your output will be reverse, right? If it is some other order, let's say somebody wants to sort on the basis of absolute value. So whichever element has the smallest absolute value, that should come first. And whichever element has the largest absolute value, that should come last. So the smallest absolute value is of 0, and then comes 1, and then comes minus 2, because minus 2 is 2 in terms of absolute value, and then comes 3. So basically my point is that currently this sort method is hard-coded. It is hard-coded to sort on ascending order. But now if I want different orders to be there, then how can I make that possible? Any thoughts around that? Like, you guys just tell me, what will you do to this class? What changes will you make inside of this class to make sure that it is extensible? It can accommodate sorting of data in any order, not just ascending order. Okay, so Aite is saying we can specify different comparators. Okay, great idea. Others? Pass some parameter in constructor. Yeah. Okay. How many of you back this idea? Because that is the very first idea that comes to a lot of heads, that pass some kind of parameter in constructor, and using that parameter, just decide that on what basis you want to sort. Okay. So let's say there is one more thing that you pass around in your constructor, and that is some sort of, let's say, you have specified some sort of enum called as order. And then you say that the orders that I would support will be ascending, descending, absolute value based, and maybe many more. They'll be added when required. Now, what I'll do is that inside the constructor of this method, I'll go ahead and pass that enum called as order. Okay. And because of that, order will also be an input that I would take. Here is dot order equals to whatever you have passed. Now think of it in this manner. If you want to sort your data in descending order, then which part of code do you think will change? This line will change, isn't it? Where you are comparing ith element with jth element, that will change. You will say, you will have some sort of multiple conditions like this. You will say that, hey, if my order dot equals order dot ascending, if this is the case, then my comparison logic will be different, right? Else if order dot equals descending, if I am required to sort in descending order, in that case, my comparison logic will be different. Else if I want to sort in some other order, let's say order dot equals anything else, whatever it is. Basically, the point that I'm trying to make is you will end up getting so many different if else conditions. And tomorrow, if you want to sort on some other criteria, let's say you want to sort on the basis of squares of the numbers or cubes of the numbers, in that case, more and more if conditions will be introduced over here. So basically, passing around an argument like this and then deciding that what should be the comparison logic of two elements, that is not an extensible solution. Because with that, there are so many if-else conditions, the readability of the code reduces, that is first point. And second point, that my code is not supporting extension at all. It is not extensible. So that is the problem with this kind of thought, which may have come to mind of a lot of people. Is it making sense? How many of you are sensing the problem with passing around something like this and then deciding on the go? So it's clear cut a problem. This thing violates a principle called as OCP. It's a design principle. OCP means open closed principle. Open closed principle means you can note this line, it is very important. It says that your class should be open for extension, but closed for modification. See, modification means you have to add new lines inside your class. Extension means that without doing anything to your sorter class, it will work without doing anything. That is extension. So how to ensure that? How to get that thing done? So here, you can think of it in this manner. Yeah, as one of you has suggested, that create an abstract class, and that abstract class probably will have few things inside it. So let's think of it in this manner. There are certain things in this code which will never change. Like, this for loop will never change. Basically, the way in which for loops run, that is never going to change. The only thing that will change is comparison of two elements. So if comparison of two elements is changing, I can think of it as a behavior that can be pulled out of here and placed inside some other abstract class. So let's say, just like animal, I create another abstract class and give it a name, comparator. So let's say this is my comparator. Okay. It will just be an abstract class, and it will have an abstract method. Abstract. That method will be compare. This compare method, what it does is it takes two integers, integer I, integer j, and it compares both of them. And probably I can make it return a Boolean, right? Now, my idea is that if compare method returns true, then it means that I should be placed before j. So if it returns true, then I am not going to swap the data. But if it returns false, then I'm going to swap the data. See, the entire thing was about swapping the data, when to swap. Like if you wanted to sort in ascending, then if the first element a of I was greater than a of j, then you wanted the swap to happen. But if you wanted to sort in descending, then that logic was different. It was in fact the reverse. So now that we have this my comparator, what I can do is that I can write different concrete implementations of this abstract class. So let's say there is an ascending comparator that I just wrote. And this ascending comparator can simply extend that my comparator. And because of that, it will be forced to implement this compare method. Now I can say that I want to implement this ascending comparator in a certain way. So what I want to do is, if the responsibility of ascending comparator is to sort the data in ascending order, then I would say that, hey, only if I is greater than j, I would want it to return true. Okay, because if I was greater than j, that means there was an element in left which was greater than the element in right, so the swap should happen. Similarly, what can happen is that you can create another implementation and you can call that descending comparator. Okay, now descending comparator, again, all that it does is it extends that my comparator class, and because of that, it will implement this method. Now here the logic will be reverse. So here the logic will be that if I is smaller than j, then return true. Similarly, you can write another comparator which probably sorts on the basis of absolute value. So let's say you want to sort your data on the basis of absolute value. You'd say you'd have absolute value comparator, which again extends my comparator and implements that method. So here it can say if math.abs, if absolute value of I is greater than the absolute value of j, then only it will return true. Now do you see what has happened? So now your super type is my comparator. My comparator has a method compare, which takes I and j and tells us whether I should come first or j should come first. So now I can fix a lot of nonsense inside this class. So I can say that, hey, now this thing is no longer needed. What I can probably require is a comparator, my comparator, which is my abstract class. Now, do you see why I have created a variable of my comparator type? It's just like animal, because animal could accommodate a dog also, cat also, donkey also, everything. So this my comparator, which is a polymorphic variable, it can accommodate an instance of ascending comparator also, descending comparator also, absolute value comparator also. In fact, it can accommodate instance of anything of any class that inherits from my comparator. So of course, I'll need to inject it inside the constructor. So let's just put it here. And then we can just say this dot my comparator is equals to whatever has been passed. Okay. Now, everything is very easy. Now, all these things can be let gone off. And now I can say that all that I'll do is if my comparator dot compare two things. What is the first thing? The first thing is my list dot get of I. And what is the second thing? It is my list dot get of j. Okay, so if this thing returns true, that means there is a need to swap. And now here I'll perform swap of the two variables. Okay, but do you see one thing? The most important thing is that now those if-else checks that I initially had have all been stripped off. They are no longer needed. Why? See, when you were introducing those if-else checks, what were you actually doing? When you were writing those if-else checks, you were writing the logic corresponding to those if-else checks. That, hey, if you want ascending, then this is the logic. If you want descending, then that is the logic. If you want absolute value based, then this is the logic. Here, that logic is being passed. That logic is being passed inside this. Because if, let's say, the instance of this is ascending comparator, then invoking compare method will call the compare which you have written over here. Okay, so all that we have done over here is the part of the code that was changing, we have localized it somewhere else and we have made it extensible. Okay, now there is a question, can we also use lambda functions? Yes, you can. That can be easily done. I mean, you can also use lambda functions, and you can also, create new comparators on the go. So right now, just for, simplicity, I had created new classes. But somebody who wants to, let's say, somebody who wants to call this sort method, he can create his own comparator, just like that is called as anonymous class. He can create something like that and pass it around here. Yeah, something like lambda function can also be done. There is no issue with that. But now when I look at this piece of code, tell me one thing. Tomorrow, if you want to introduce a new kind of comparator, let's say you want to sort the elements on the basis of their squares. So the element whose square is smallest should come first. So 0 has the smallest square, so it comes first, then 1, then -2. So if you want to sort on any other random custom basis, do you believe anything will change inside this class? Just think about it. Will anything change? No. Where will the change happen? The only change that will happen is you will have to add a new class, and that new class will implement the abstract comparator that you have written. So let's say you want to introduce your new comparator, my new custom comparator. Now this, your new custom comparator, it can implement, sorry, it can extend that particular class, which was my comparator. And because it extends it, so it will have to implement compare method. Now, whatever is your logic for comparison, for comparing the two items, no matter how complicated or how simple that logic is, you put that logic over here inside these two blocks. And now because this my new custom comparator extends my comparator abstract class, so it can be passed inside sorter, and sorter will work as it is. Few things to note over here is that this class, when you look at the sorter class, it depends upon polymorphic type. Because it depends upon polymorphic type, when I say it depends upon, I mean that its variable is a polymorphic type. Because its variable is polymorphic type, that is the reason you can inject different behaviors inside it. I mean, you can pass ascending behavior, descending behavior, whatsoever you want. Tomorrow in the future, if you want new behaviors, then this class is not going to change. Only new classes will be added, and the objects of them will be passed over here. So this is designing for extension. Now think of it in this manner. Let's say a company is currently writing a library, is in process of writing a library. And after writing that library, it wants to make it open source. So, this was a component of that library, and it contains a very, very intelligent sorting algorithm. And now that sorting algorithm is, let's say, a little faster than merge sort and quick sort also in terms of constant number. Then basically the sorting logic has been written over here. And the thing that could change, which is comparison logic, the thing that could change, that has been made polymorphic, so that clients who are the users can just create their own version of comparator and plug it inside the same class, and that class will work like a charm. So it's like whoever is the builder, whoever is the creator, is basically allowing the clients to plug and play with their own version of changeable things. Okay, so this has set the tone for our first basic design pattern, which is called as strategy design pattern. Strategy design pattern simply means, see, what is this? This is a strategy, comparison of two different items. That comparison algorithm, that comparison logic could vary from situation to situation. Okay, so basically that is, people refer to that as a term strategy. So if you have different strategies for something, in that case, what you can do is you can make all those strategies like ascending comparator, descending comparator, you can make all those strategy extend a common type, a super type, and then your actual class can depend upon that super type. As simple as that. Okay. Now, it also means one very, very important thing. So let's say if this class has to compile, then do you think it will wait for ascending comparator, descending comparator, my custom comparator? Will it wait for these many classes to compile? Does it have a dependency over them? The answer is no, not at all. The dependency of your current class, which is sorter, is only on the abstract class. So if this abstract class compiles fine, then this sorter would also compile well. Okay. So there is one design pattern also which is associated with it, that is called as dependency inversion principle. It says that if you want extension, you should depend upon abstract types. You should depend upon polymorphic types. See, whether I say abstract or polymorphic, they mean the same thing. If you depend upon polymorphic types, you have designed for extension. And that is what you should actually be doing. So when you just read that statement, it does not make sense. But now you might be getting a lot of idea that, hey, why to depend upon abstract types? Why does it make sense? DIP is dependency inversion principle. It simply says that instead of depending on concrete classes, you should depend upon abstract or polymorphic classes. See, if I would have wanted, I would have just said that, hey, my dependency is ascending comparator. But if, let's say, the type of this thing was ascending comparator, in that case, this class would not have been extensible. Here, this is of polymorphic type, so you are able to inject different behaviors over here. So dependency inversion principle simply says, try depending upon the abstract types for the things that can change. Okay, that's all that it kind of says. Okay, so like this was a very simple way to understand a strategy pattern, but it has enormous applications. Anyone who would like to quote a very much encountered usage of strategy pattern? Have you encountered a software, or have you played with any application, any software application, and you saw a feature and you found out that, hey, that feature must have been coded using strategy design pattern? Anything that you can relate around that? What is it that you probably found out and you felt like maybe even you can try recalling now? I'll give you a very beautiful example. All of you use IDs. In IDs, you can put some plugins. Have you ever placed any plugin inside Eclipse or IntelliJ? Or have you heard of it? So why do you put plugins? So let's say you have Eclipse, and now you put a plugin for HTML, CSS, so that you can compile the code of HTML. You can get auto suggestions and all sorts of things. What is that plugin? That plugin is just like a variable that is passed for a polymorphic type. So let's say there is a class that manages your entire IDE. Now I'm calling that class as manager, and that manager class, it has a polymorphic type called as language support. Okay. Now that language support is polymorphic type, and Eclipse has its own implemented versions of those. So let's say for Java, it is there. For C++, it is there. And if you want new ones, you can probably download from internet. So from internet, if you download a HTML or CSS plugin, and if that plugin implements that polymorphic type language support, then it will work well like a charm. So if it implements that plugin, that interface, it would definitely implement some common methods that it has. So let's say there is a common method called as compile. Compile is a method that is written inside the abstract class, right? And if the plugin software that you have downloaded, if it is coded against that interface or against that abstract type, then what it means is that it will just work like a charm. Because it's just like saying that from internet I'll download a new comparator and pass that comparator over here. It's similar to that. Plugins also work in pretty much the same manner. From internet, you download a new plugin, and as long as that plugin software implements the interface, the common interface or common abstract class which is exposed by Eclipse, it'll work like a charm. It'll help you build and compile and get suggestions for whatever language you are working on. So these plugins are a very, very classical case of strategy design pattern. So you can also write your own plugin for Eclipse. How? You can see the common interface that Eclipse offers, and you can basically implement that interface, and you can publish that software. Now somebody can just use it. Is it making some sense? Are you guys getting a feel of how I'm trying to relate plugins to be very, very similar to a beautiful, outcome of strategy pattern? Yeah. Okay, great. Now, you might have seen a lot of softwares where interfaces have been used, abstract classes have been used. Interface is also like an abstract class only. There are few differences. I'll not go into those. Those are, while I'll be coding some interfaces, that will be clear. But understand, interface and abstract class, both of them are abstract types only, which just declare the method but do not implement those methods. Okay. Now, let's quickly design something using whatever we have learned. So let's say somebody asks you that, hey, I want to consider it as a case study asked to you in an interview. Somebody says that, hey, I want to design a system that can read strings, okay, and then convert those strings into certain formats, and then write those strings. So this is an interview question from me to you. Think of it in this manner. Now that you have learned strategy pattern, your interviewer, if he knows that you know strategy pattern, he might want to ask you questions around these. So let me help you understand. So I want to basically build a system which can do things like these. For example, read strings from a file. It could be a file on your file system, on your local file system. Read strings from a file, and then, so that is this part, okay? And then converts those strings into certain format, let's say into comma separated format. So this is the second part. And the third part is that then finally it writes those strings to the console. So this is one requirement. So I want to design a system. I want to write a piece of code that reads strings from a file on your file system, and then it converts those strings into some format, let's say comma separated format. And then whatever that comma separated format of string is, it writes those to your console. But this is a very, very specific requirement of this thing. When I say read strings, it should be able to read strings from anywhere. It should be able to read strings from console also. So I might say that now my code should also be able to read strings from a console, convert those strings into not comma separated format, but uppercase chars. So basically, it uppercases all the characters and then writes those strings to some file on my file system. So this is another specific requirement that comes out of these generic requirements. Okay. And then it can just grow with time. Somebody can say that, hey, I should be able to read strings from a file that is present on Google Drive. And then I should be able to convert those strings into a beautiful JSON. And then I should be able to write those strings somewhere on the Elasticsearch or Cassandra, anywhere. So such kind of system I want to build, which can read from anywhere, string only. For right now, let's just assume string, which can read strings from anywhere, which can convert that string into some other string, and then write that to some other location. It could be writing on your console. It could be writing on your local file system, on your remote file system, anywhere. Is the requirement making sense? How many of you are getting a feel of that? Okay, so tell me, how would you want to go about it? All that we have to ensure is our system should be generic enough.
Sure, I'd like to give it a go. I'm on this side.
Yeah.
So we'd like to have an abstract class around read, right? And then an abstract class around the type of the file of the format or whatever it is to which we want to convert. And then another one to where we want to write. Have those abstract classes and then have a generic class which kind of calls all these methods, and then we can pass in the different comparators or whatever we say it in this way over here, like the types and everything. And in that way, we wouldn't have to change the general function. And whenever we want to add additional things, the other function, the other read files and write things can be added up. It will keep the open close principle in check, and also the DIP thing. Yeah.
Cool. Great. So let's think of it in this manner. In any case study, the most basic thing is to figure out the components. What components are there? Yeah, there are different steps that you have to take for solving any case study. As we move ahead on by day 3, day 4, I'll expose all those steps to you. But the most basic step is to figure out components. Do you see that by looking at the requirements, I can clearly see that there are 3 components over here. The first component is a reader. The second component can be thought of as converter. And the third component can be thought of as a writer. So there are 3 components. Is it making sense? Why I have highlighted those 3 components? Yeah. Okay. Now, according to the question, I am supposed to implement these components in an extensible way. So as Aman has mentioned, some of you might have resonated with it, but could you find it that this reader cannot be a concrete class? It should be an abstract type. Similarly, this converter also should be an abstract type. This writer should also be an abstract type. It can either be an abstract class or it can be an interface, but it should be an abstract type. Why? Because when you say read, if reader has a method inside it, and that method is read, what will be the signature of this read method? Tell me. Read will not take anything. It will simply return you the string that it has read. Let's say this is the signature that we have agreed on to. Now, the implementation of this read method will vary from reader to reader. If you have a reader that reads from console, then probably it will create an input scanner or a buffered reader, and then it will try to read from the console. But if you have a file reader, in that case, it will create some file reader, and in that case, it will read byte by byte from the file. If you have a reader that reads from Google Drive, so basically the algorithm or the strategy to read from different sources will be different. So I am planning to make this reader as an abstract type. So I have created an interface, a very simple interface called as reader. Imagine it just like an abstract class, and it exposes a method string read. Is it making sense that why reader is an interface and why it has this method? Okay. Others, can you relate to it? Similarly, can you think of an interface for converter, and similarly an interface for a writer? The question is, what is the possibility if our right values are n number of options is recommended everything to create a new class? I think you're asking two different questions. I'm a little unable to read between the lines. The question is what is the possibility if our right values are n number of options? Is your question something like this, that if there are 10 different kind of writers, then create 10 different classes? Is this what you are trying to ask? Yes, the answer is yes. That is why abstract types or interfaces are created. See, even if you remember the example of this sorter, because you have written a polymorphic type and different classes are coded against this polymorphic type, so this sorter is safe. This sorter will never ever change, right? The same thing is to be, taken care of everywhere. Only if you see that there is certain part of your code that changes, then you extract that thing out from your code, create an abstract entity for it, and then write multiple concrete implementations for that. The same thing we'll be doing here also. So you can see that there is a reader interface, and then there is a converter interface. So converter, what it does is, it takes in a text and returns another text. So whatever the reader has read, it will pass to the convert method, and that convert method will then uppercase it and return another string, or lowercase, or whatever it does. Basically, that is the idea. Okay, so this is the signature of our converter interface. Similarly, if you look at writer, it does not return you anything. It simply takes a text and it writes it wherever you are supposed to write. Okay, now this reader can have different implementations. Okay, so you can say that this reader can, there is a particular kind of reader that is, have written a reader for you already. Let's say console reader. So console reader, you can see what it does is it scans from the console and returns you that text. Similarly, you can have a file reader. So file reader has its own read method. Here, it will do something else. It will deal with the files. Similarly, for converter, if you write different implementations of converter, you can write an implementation called as uppercase converter. So uppercase converter, what it does is it uppercases all the text one by one. And then you have a JSON converter, which basically creates a JSON string and returns that string. That all it does. Similarly, writer can have different implementations. There can be a writer that writes to file. There can be a writer that writes to console. So these are the three different entities that we have created. Devansh has asked a question. See, right now we are, because I wanted a simplified form of question, so I just said we are just dealing with strings. We are not dealing with any random type. That is the reason I could very easily come up with signature of all these interfaces. If you have a type which is not just string, it could be an object, there you might want to use generics, but I'm keeping those away for now, because right now I just want to focus upon the strategy pattern and not on the generics and other sort of things. But everyone gets these three different interfaces that we have written. Now, let's say you want to write a manager on top of those. Then you can say that this manager, it will depend upon those three abstract classes. So it will have an instance of, it will have private final reader. Okay. And it will have private final converter. Okay. And then it will have private final writer. Now it'll have a constructor wherein you can pass these things. Now, let's say it has a method, public void start. So now just see how this method, how this start method works. This start method does not care about whether the reader is a file reader or console reader. It does not care where you are writing to, whether you are writing to Google Drive or you are writing to Elasticsearch. It does not care about all those things. All that it knows is that it has been passed three items, such that first item is an object that implements reader. second item implements converter, third item implements writer. So all that it will do is it will call read method, then convert method, then write method, and that's it. That's how its job will be done. So probably it will say reader dot read, and that way it will get its string. Let's say I'm calling it text. And after reading that text, call converter dot convert. It will pass in this text, and after that it will get some altered text. String. Altered text. And then finally, it will write that. So it will do writer dot write altered text. Do you note one thing? How simple this code is and how extensible this code is. Somebody looking at this piece of code would say that this piece of code can read from anywhere, convert to any form, and write to anywhere. This is the power of extension. And this is what strategy pattern endows you with. In future, you can write your own version of reader, converter, writer, but this code is not going to change. The core logic of this code is just to invoke read on the reader, convert on the converter, and write on the writer, and do these things in the proper sequence. And it is doing that. The nuances of actually reading, the nuances of actually converting, the nuances of actually writing is hidden inside the implementations of reader, converter, and writer. Is it making sense? How many of you could follow me on this? How many of you are aware of caching libraries? Have you ever used any cache like Redis or any partner of that? Yeah? Okay. While using libraries, have you seen that just by making one line of code change somewhere in some configuration file or maybe in your code file only, you can completely change the behavior? I mean, let's say if you're using cache, every cache has its own eviction strategy. If your cache is full and if you want to evict the data, there needs to be a strategy for eviction. So sometimes you might want to let go of least frequently used or least recently used. So there are different forms of eviction strategies. Do you feel it is a classic case of strategy pattern? The answer is yes. So there you can imagine cache is just like a class, and that cache class has an argument inside it, has an instance variable inside it, which is strategy, eviction strategy. And that eviction strategy is a polymorphic type. It's an interface. Okay. And if you specify in your configuration file that, hey, the eviction strategy that I want is LRU or LFU, then automatically an instance of that eviction strategy is passed to that class and it works like a charm. So this strategy design pattern is extremely helpful in writing extensible systems, in writing, software that you can plug and play with quite easily. And it abides by two most important design principles that I said at the beginning. Open closed principle. What is open closed principle? Your class is open to extension. See, this manager is open to extension. It says that, hey, go ahead and create different kinds of reader. I will not change. I will continue to work as I am. Go ahead and create different kind of converter, writer. I will continue to behave the way I am, right? So it's open closed principle. The last one, the second one is dependency inversion principle. So it says that, hey, my dependency is only on reader, converter, and writer, and they are simple interfaces. So as long as they compile fine, I compile fine. I do not worry about how many different kinds of readers do you have in your code base, how many different kinds of converters do you have in your code base, how many different kind of writers do you have in your code base. I do not worry about that. It does not know that, right? So this is a classical case of, decoupling things also, where your manager does not really worry about different forms of reader, converter, writer. It just knows those abstractions that, yeah, reader is an abstraction in which there is a read method, converter is an abstraction in which there is a convert method, writer is an abstraction in which there is a write method. Questions? One question, we need to have multiple objects created for different writers. Are we using strategy pattern for object creation? No. For object creation, you will have to actually create them. So think of it in this manner. This is your manager class. Now, let's say you have your own class. Let's say its name is my class. Inside my class, you will have to do a new of console reader, new of so-and-so converter, new of so-and-so writer, and pass those inside this constructor. You'll have to do that. Another ways, if you do not want to use new keyword, you can use factory pattern, which we are going to learn on the last day, which is 5th day. Okay. Yeah, so by the end of this 5-day affair, you will see that these design patterns, they work in unison. So if you are working on a case study, let's say you are designing Amazon or an e-commerce, you will see that so many design patterns are used in a hybrid manner to actually solve a problem. Okay. This was the simplest one. Strategy pattern was the simplest one. It was just like opening the lock for you so that now you have some appreciation for LLD, at least that, yeah, design patterns. Otherwise, a lot of people, when they look at the code base where people have used so many abstract classes, interfaces, you might have felt it when you would have been a junior developer, or you might have been a fresher. Did you ever feel it that, hey, why so much of abstraction? It's very, very confusing. You might have felt it, something like that. You might not have been able to bring an appreciation for them. But if you understand these patterns and principles in depth, you will feel that, yeah, they are really incredible. They are really, really beautiful. The existing comparator of Java is an interface. All of you know that. How many of you have used comparators in Java for sorting? Let's try to show you. It's not comparator, it's called as comparable. So I'll take you to that official Java class. You can see comparable. It's an interface in Java. The author is Josh Bloch, and you can see that this is the method that it has. So strategy pattern, it's actually used by the people who have coded libraries of Java to make things easy for people like us, so that we can easily sort our list. We can easily get a lot of things done by plug and play. How we decide strategy need to be used if there are no much changes rather than 3 to 4 values. Strategy pattern is not about values or data. It's about behavior. Strategy, what is strategy? Strategy is behavior. When you see that there are multiple ways of doing a certain thing, the only thing is that the algorithms are different. In that case, you use strategy pattern. Like here, I found out that at the end of the day, I have to read a string. But the algorithm used to read that string, it's different for reading from console. It's different for reading from file, different for reading from Google Drive or anywhere. So when you see that the action that we have to do is same. So when what is same, see what is to be done, data is to be read. But how that is to be done, that is different. How is different. If what is same, but how is different, then that's a classical case of strategy design pattern. Do you connect to me on this? I think this can be a summary of strategy pattern as a whole. What you have to do is same. Converter. It has to take a string, convert it into another string. But how it converts is different, right? Writer. It writes a string somewhere. But how it writes, that is different. So whenever you have these portions in your code, and if you have not used design patterns, you will see you must have used if-else conditions for them. If so-and-so, apply this logic. Else, apply this logic. Else, apply this logic. There, you can just remove all those things and create a polymorphic type, declare the abstract method inside that, and then do whatever we have done today. Yeah. This is what abstraction is. You abstract out things. You pull them away from here and put them elsewhere and make sure that they are coded against the same super type. so that your actual master class is extensible. Yeah, enough for today. Okay. Usually it's very easy for people to find things like low-level design boring. I hope you guys kind of enjoyed it. Tomorrow when we meet, we'll try to enjoy it more, because it's really a beautiful thing to learn and know and to grow up in the software development ladder. Yeah. Okay then. Bye everyone.